I grew up in a very working class outer suburb of Melbourne, Australia. No one in my family had ever been to university. It's actually statistically very improbable that I'm standing here right now in Vienna about to talk about, well, really the future of humanity, with some extremely new scientific results about the psychology of galactic empires. So mine's no sob story. Although working class, my parents understood the importance of perspective, of example. They wanted us to know what was possible, myself and my 5 siblings. They exposed us to things. They, for example, Sunday afternoons were spent listening to BBC science shows on the radio. Lots of dignified old British voices talking about the magnificence of the universe. It really instilled in myself and my siblings this sense of curiosity that we helped each other to maintain and has carried us through our lives. And for me in particular, it showed me something that I didn't really know at that point, and that was that it was possible to have a career talking about and doing science. Knowing what is possible helps make things possible. That's also true of populations. So communities, nations, and back in the day, tribes inspire each other, influence each other by sharing art and science and wisdom. And a feedback process propagates them all forward. With humanity, this took a long time. We spent 200,000 years as hunter-gatherers on the savanna of Africa before a degree of mutual sharing, the feedback propagated us to this elbow of the exponential where we find ourselves today. We are now on the verge of taking command of our own genome, of creating artificial intelligences, of understanding the very origin of our universe. And by the gods, we have rocket ships. As a civilization who is more than ever acting in a unified way as a species, who do we look to next? Where is our example? Where is they that came before us reaching down their hand to show us the way to whatever that next transition is? And this is a question which we've been asking ever since we thought it might be that there were others, that there were others out there. It seems like a great time for a famous quote. Arthur C. Clarke said that 2 possibilities exist. Either we are alone in the universe or we are not. Both are equally terrifying. And when he said this in the 60s, we had never seen a planet around another star system. Our surveys of the galaxy were in their infancy, as were SETI programs, searches for extraterrestrial intelligence. We didn't know whether there were aliens, but we hadn't really looked. For all we knew, the galaxy could have been terrifyingly full of technological civilizations. But now we have surveyed large chunks of our galaxy. The Sloan Digital Sky Survey has taken spectroscopic observations of more than 2.5 million stars. Those stars, almost all, have planetary systems as discovered by the Kepler Space Telescope, watching the minuscule dimming of light as distant alien worlds pass in front of their parent star. We've now determined that almost every star in the Milky Way has a planetary system, and there are tens of billions of terrestrial, so Earth-like planets with the potential to have life-loving liquid water. And then there's the TRAPPIST-1 system. The TRAPPIST telescope found a star only 10 light years away, which is our most immediate cosmic neighborhood, that has 7 terrestrial worlds, many of which are potentially habitable. The number of potential places for life in our galaxy has skyrocketed over the past few years. Many of them may have life, and in fact, when we turn our science inward, when we look at the Earth and what it can tell us about life, we know now that many of them probably do. So we peer further and further back into Earth's history. This is a fossil of layers of slimy algae, dated at 3.7 billion years ago. Okay, this is a stromatolite found in Greenland. There are similarly old stromatolites at 3.5 billion years found in my hometown, well, my home country, Australia. And even more intriguingly, this is an Aussie zircon crystal. Those little patches are little pieces of carbon with a strikingly biogenic isotopic ratio. It looks like that carbon came from life. And this thing is dated at up to 4.1 billion years old. The latest, only this year, hematite formations that look for all the world like the types of little hematite tubes built by bacteria in deep-sea hydrothermal vents. This thing, 4.2 billion years old, within a cosmic eye blink of Earth's coalescence from space dust 4.5 billion years ago. It seems that life happens quickly and with great probability when the conditions are right. It certainly did on Earth, and there's no reason to believe that it wouldn't do the same elsewhere. From what we know, the universe, the galaxy should be full of, at the very least, slime-covered planets. Why shouldn't some of them also followed our developmental path and produced technological species before us? Well, we certainly don't see them. We've been looking with our best radio telescopes for half a century now, but the galaxy is silent. The Sloan spectra of stars slavishly obey the known laws of stellar physics. Galactic radio chatter is non-existent, and everything just looks eerily natural. There are a couple of exceptions. There's this one star, Tabby's star, in the Kepler sample that appears to be dimming in strange ways. People talk about it being an alien megastructure. It almost certainly is not an alien megastructure, although almost as I was flying here, the announcement came that it had started dimming again after a 2-year break. And so we will know very soon whether we need to redact this entire talk. It's probably not an alien megastructure. But regardless, it's very clear that if anything like us exists out there, they are stunningly and surprisingly rare. So this tension between the apparent abundance of potential places for life to begin and the complete absence of any evidence that anything like us has ever come before is, of course, termed the Fermi paradox, after the great physicist Enrico Fermi, who famously asked in 1950, "Where is everybody?" The Fermi paradox is only more paradoxical today, knowing what we now know. So the Fermi paradox is about timescales. Our sun is about 5 billion years old, but the Milky Way galaxy is more than twice that age. There are countless stars just like our suns, just like our sun, countless solar systems just like our solar system out there, many of them with billions of years lead on us. But a cosmic eye blink of a lead in development is countless generations for a civilization that managed to come ahead of us. What could they do with those generations? I don't know, fill their part of the galaxy with light-collecting Dyson spheres, send exponentially multiplying colonization waves or maybe interstellar travel is actually almost impossible, still, self-replicating automated probes proposed by von Neumann in the 50s could fill our galaxy in that cosmic eye blink. And if you're the stay-at-home type, vast beacons sending electromagnetic radiation for us to detect, powered by cosmic power sources. We see none of this, obviously, but it would only take a small number of them for them to be very, very apparent. In the absence of evidence of a mentor race, of anyone coming before us, can we at least take that absence as some sort of guidance? The answer to that question, well, to answer it is to solve the Fermi paradox. The solution to the paradox is often framed in terms of a great filter, some stage in development that is so difficult or so improbable to get past that almost no one ever does. And the interesting question becomes, is that stage behind us or is it ahead of us? Are we lucky and are we unique in the galaxy at having somehow got through a very difficult developmental adolescence to reach our current space? Or are civilizations like us super common? It's happened many times in the past. A civilization builds some cities, has a fledgling space program, throws a few nice conferences, and then bam, with stunning efficiency, in fact, perfect efficiency, they all wipe themselves out down to the one. Well, that's a compelling question. I think even Arthur C. Clarke would agree that that is the more terrifying potential option. And the good thing about our current position is that we actually do have some information now, finally. We have a single data point that's going to allow us to make an educated guess about where that great filter is and what that means for our next step. So, if that filter is a catastrophe, that's bad, but it's not necessarily a catastrophe. It may be that in the future, advanced civilizations become, let's say, inscrutable. Right now, humanity is all about unfettered expansion. Epic acts of galactic graffiti sound fun. But surely with godlike technological advancement also comes a similar measure of cultural, sociological, psychological evolution. Perhaps once you have the technology to reach the stars, you are immediately inclined to enter a galaxy-wide state of harmony in which, with perfect efficiency, you enforce a prime directive. Stay hidden until we are worthy of seeing you. Or perhaps, to a civilization, they all turn inwards into impossibly complex virtual worlds and lose complete interest in the stars, in the galaxy. Or perhaps our ant-like intellects can't even hope to fathom the motives of an advanced civilization. Perhaps our ant-like capacity to sense can't sense their godlike technologies. How does an ant-like intellect attempt to understand the motives of an advanced civilization? How do we guess at a galactic empire's psychology? And that's the new piece of information that we have developed over the past 10 years. We have not ever found a galactic empire. We haven't seen any aliens, but we have located one proto-galactic civilization that seems to be within a handful of generations of being able to make the sort of mark on at least one system that could be detectable from a large distance. It might not, but the probability is increasing that it should be able to. I'm talking about us, of course. Okay, to clarify. The Kepler program, okay, the Kepler Observatory was a collaboration between thousands of scientists under the auspices of an enormous national space program. I'm talking about NASA, of course. In a sense, we could say that Kepler was the will of the people. It was subject to the budgetary approval of elected officials. In the past, giant science programs like the Sloan Survey were conducted by hundreds or thousands of scientists, dozens of research institutions. Big science was always very collaborative, very collective, very egalitarian. The biggest science, like the Apollo program, which put the first person on another world, took nations. JFK said, "We choose to go to the moon." Will we choose to go to Mars, to mine the asteroids? Will we choose to engage in large-scale astroengineering projects? Will we choose to send probes to other worlds? No. We won't choose. These things are almost certainly going to be initiated by individuals. Right now, there are a handful of companies, private companies, that are currently operating spacecraft to low Earth orbit, and many more with both craft and other space programs in development. Yuri Milner provided the seed funding for the Breakthrough Starshot program, which has every chance of placing a probe, admittedly a tiny one, in the nearest star system within half a century. We don't choose to do these things. You choose. And by you, I mean anyone with the talent and the passion and or the billions to bring enough people along for the ride. There are currently a handful of people with levels of autocratic control over entire space programs. That number is only going to increase. Within generations, it'll be hundreds of a million at a minimum. And the bar is now getting so low. Technological advances in the future, reusable rocketry, advances in propulsion systems, our capacity to engineer in space, 3D printing on the moon or Mars of entire structures, the unlimited and almost unthinkable resources of the asteroid belt will propel projects that we can't even conceive of today. These things seem very likely to happen. We are at the elbow of the exponential. Things like Dyson spheres and von Neumann probes are not the far future of humanity, they're the near to medium future of humanity. They might not happen, and we don't know where we'll proceed beyond that elbow. Maybe nothing will come of it. But we now know what the chances are, and they're certainly not zero. There are many paths past that elbow which leave an indelible mark on our solar system, if not our part of the galaxy. And that mark answers Fermi's question. Where is everybody? Hey guys, we're right here. So our technology is fast outpacing our ability to choose collectively whether or not to use it, whether or not, for example, to go to the stars. There's really no reason to believe that other civilizations who reach our state will do so uniformly with less individualistic motives that we present in this current state. We are a perfectly good model for the psychology of an advanced civilization, assuming we're a perfectly good model for the psychology of ourselves in 100 years or 200 years. So you give a civilization like ours, or, any one of the many that came before us, just a handful of generations doing what we can do with our current pace, and honestly, some crazy stuff is going to be tried. So, why is the galaxy so quiet? Well, if we do take ourselves as a model, then it means that no one else survives to our state. And it's a little bit hard to escape that conclusion given the numbers. That's a little bit gloomy, but I think also our exponential progress gives us some hope. If we're going to wipe ourselves out, okay, we're going to have to do it quick. The clock is ticking. We only have a small number of generations to obliterate our civilization, back to the Stone Age perhaps, before we're capable of making that mark. And even if we do so, we know that we might not. So by that model, someone before us, 1 in 100 even, 1 in 1,000, would need to get through our current teething state to make that mark, okay? And yet we don't see it. For that reason, I think the answer is a little more cheery. I think the more probable solution to the Fermi paradox, given the latest information about how we will proceed forward, or at least try to, is that the filter, although it exists, it's behind us. There is something special about humanity. Don't get cocky. It could have been way back in the evolutionary tree, maybe that chance fusion of proto-eukaryote, proto-mitochondria to forge the modern complex cell is 1 in trillions. Or perhaps it is humanity. Perhaps there was a rewiring back on the plains of Africa. Homo sapiens suddenly learned how to think in different ways. Yuval Harari would say that we learned to believe fictions. We learned to believe in things like a destiny, galactic empires, but imagined futures. And it set our eyes first on the world and then on the stars. So we look at the galaxy and it appears like an untamed natural wilderness, trackless. But I really think that we can take some incredible inspiration from that fact. There may not be anyone to show us the path, and that means that we find it ourselves, that we make the track ourselves. Whatever lucky chance led us to here, whatever it is that's slowing down every other possible incidence of something like us, has placed us in a position to potentially be early. What if we're early to the galaxy? And what if a destiny that we could choose is that we become the ones to forge that path, to lend that helping hand to anyone who happens to come after? Thank you.